Hi everyone, so today we're going to go ahead and solve trig equations using algebra. Okay, so with this question, what we're going to do is we are going to go ahead and solve by factoring. So what you should notice is that both terms actually contain a cotangent. So if I take out that common factor of cotangent, what I would have is cotangent of x, and then I would have a plus 1, and that would equal 0. Now, what I want to do is I want to say, okay, well, if this equals 0, I can set both of my factors equal to 0. This would give me two equations here. And it would just be like solving a factored quadratic, right? We give our two separate equations. What you will do is isolating that trig function. We're going to go ahead on this second equation. We are going to subtract 1 from both sides. So we're going to have our two separate equations with our trig function that is isolated. In order to solve, what you're going to think about is where cotangent of x would be equal to 0. So now what you need to think about is cotangent is the same thing as me saying that this is cosine of x over sine of x. Now, if cosine of x over sine of x is equal to 0, cotangent of x would be 0 when my cosine is 0. So you need to think about where on your unit circle cosine is equal to 0. Well, that would be in two locations. That would be at pi over 2, and that would also be at 3 pi over 2. So here is where we have our two angles. So now what I'm going to think about is where cotangent of x is equal to -1. So again, remembering that cotangent is the same thing as cosine over sine, well, I want to think about where is cosine over sine is going to equal -1. That means that cosine and sine have to be the same, right? So in my unit circle, what I'm going to think about is, so I know that cosine and sine are the same at two angles. The first one would be in quadrant number 2, and the second one would be in quadrant number 4. Now remember, you need to think back to where cotangent is going to be a positive answer. So you know that it can't be in quadrants 1 or quadrants 3. So my angles are going to be in quadrants 2 and quadrant 4, and that would be 3 pi over 4 and 7 pi over 4. So with my orange, what I have, my two angles, is pi over 2 and 3 pi over 2. And then in my blue, I have my two angles that are 3 pi over 4 and 7 pi over 4. So now remembering that our solutions are in radians and they're going to be in this interval between 0 and 2 pi, but not including 2 pi. So here are my values for x. Okay, so in this third step, we are rewriting the answer for all the x's. Something you need to remember is that whenever a trig equation repeats, it repeats every 2 pi, right? So what we do is we are saying that we have our solution, and then when we're repeating every 2 pi, we're going to add 2 pi and n. Now, n is going to represent any integer, okay? So when we write our answers, so the first answer I'm going to take is I'm going to take that pi over 2, and because my trig equation can repeat that 2 pi, I'm going to add 2 pi, and then my n, which represents that integer. I'm going to take the same thing for 3 pi over 2, which is, again, here's my solution, and it can repeat, so it can repeat every 2 pi and then n. Now, same thing for our blue angle, so that was 3 pi over 4 and 7 pi over 4. Again, we can repeat, so we're going to add 2 pi n and 2 pi n. So there is another way that you can write your answers. So we're going to look at this first orange two answers here. Now for when your cotangent is equal to 0, right? You got your two answers of pi over 2 and 3 pi over 2, okay? But remember that these angles are actually 180 degrees or pi radians apart. So your pattern actually repeats every pi, right? Every amount or distance of pi. So you can write your answer in another way, right? So sometimes you can see this as x equals and then pi over 2, and then it repeats pi n. So you can write this instead of 2 pi n, you could write it as pi n. And you can do the same thing as for the cotangent for equaling to -1. So 3 pi over 4 and 7 pi over 4, also pi distance apart. So you can combine sort of in one general solution. So another way for you to rewrite this would be 3 pi over 4 and then repeating every pi, and then n standing for your integer. Okay, so in this question, we're going to solve by factoring. And again, if you're having a little bit of a hard time being able to identify how to factor this, remember that if you were just to replace cosecant with x, this would be x squared plus 3x plus 2. So if that would help you to factor a little bit easier, you can do so. So that would be x plus 2 and x plus 1. But because we took out that cosecant and just made it as an x to make our factoring a little bit easier, you're going to have to put cosecant back in. So my factoring is cosecant of x plus 2 and then cosecant of x plus 1, again, still equal to 0. So what you have here is, again, if you were to set your factors equal to 0, you can isolate your trig functions, which would get you cosecant of x equals -2 by subtracting the 2 and the 1 to the other side. Okay. So something for you to think about is cosecant, right, is actually the reciprocal of sine. So we want to have our functions in terms of sine or cosine just because we can figure out sine and cosine a little bit easier on our unit circle. So if cosecant is the reciprocal of sine, well, if I want to rewrite this as sine, I know that I'm going to have to flip my fraction here. So -2 becomes -1 over 2. And the same thing would go with my second equation, right? I would flip, but 1 over -1 is still the same thing as -1. So that actually works out. So that's perfect. What we're going to do is we're going to figure out what our answers are, right? So I want you to think about your unit circle, right? And I want you to think about where would sine be a -1/2. So -1/2 would be right here and right here. So we have two answers. That would be a 7 pi over 6 and 11 pi over 6. And then for my second answer, I have where would sine of x be -1? And that would be right down here. And that would be at 3 pi over 2. All right, so you get your answers. Now rewriting all of your answers for x, right? So just take each answer you got. So 7 pi over 6. Again, remembering that we are repeating every 2 pi with our integer of n, right? Infinite number of times you can repeat. Do the same thing for 11 pi over 6 plus 2 pi n. And our last one is 3 pi over 2 plus 2 pi n. Okay, so here is our next question. What we're going to do is we are going to solve using our square roots. Okay, so we're going to isolate your trig function here. So what we know is we're going to have to add 2 to both sides. So that's 3 tan squared of x is equal to 9. I'm going to divide both sides by 3. So I get tan squared of x is equal to 3. So now remember, I'm trying to isolate that trig function. So I am going to go ahead and take the square root of both sides. Now, you need to remember the plus or the minus. When you take the square root, you're going to have to remember the plus or minus. So you're going to get tangent of x is equal to plus or minus the square root of 3. Okay, so now we're going to go ahead and figure out where this is on our unit circle. Okay, all right, so the first thing you want to think about is tangent. You need to remember is the same thing as y over x, right, which is sine over cosine. So let's figure out where we would be on our unit circle. So now we need to think about where I get the square root of 3. Well, that wouldn't have to mean that I would get root 3 over 2 over 1/2, because remember that our 2's would cancel and I would be left with root 3 over 1, which would get me the square root of 3. And now I want you to think about where that point is. So that would be this angle right here and this angle right here. Again, let's just tell you what that terminal point is, right? That is the negative 1/2 and the root 3 over 2, right? That's my y and my x, okay? So with that, I'm going to figure out that would get me the answer of the negative root 3 that I had wanted, okay? So now think about again, right? Where would I have another angle, right? I'm still trying to get the positive root 3, right? The positive root 3. It would have to be the same, right? It'd have to be root 3 over 2 over 1/2, because I would get the positive root 3 that I want. So that would be this angle right here and this angle right here. Okay, because again, remember what that terminal point is. It's 1/2 and then root 3 over 2. That would give me the positive answer. Okay, so let's get those angles. So the first angle is this one right here. That is pi over 3. The second one is down here, still pi distance apart, right? That's 4 pi over 3. All right, so my other angle was right here. That was 2 pi over 3. And our last one down in quadrant 4 was 5 pi over 3, right? So you have all of those 4 angles. So now let's write our answers for all the x's. So again, take each of your angles. You have pi over 3 plus 2 pi n. You have 2 pi over 3 plus 2 pi n. I'm just going to write our angles in order. You have 4 pi over 3 plus 2 pi n. And the last one is 5 pi over 3 plus 2 pi n. So now I'd like for you to think about, well, how could you sort of rewrite these? Now, again, remember, this one is optional. You don't have to do this, but there is a way that you can rewrite it. So think about what is pi distance apart, right? So the angles that are pi distance apart, so the first one would be pi over 3 and 4 pi over 3. So those are pi distance apart. So you can say that x is equal to pi over 3 plus pi n. Again, remember, that's just the repeating. And then the next you can say is these angles right here. You can say that those, which is 2 pi over 3 and 5 pi over 3, that's again pi distance apart. So you can say that's 2 pi over 3 plus pi n. So just another way for you to be able to write it, right? But again, these would be sufficient enough for your answers. Okay, here we go. Let's go ahead and solve. So what you're going to see is that you do have 2 different functions. Okay, so the first thing I want you to do is I want you to see that tangent squared identity, we can actually rewrite that as secant squared x minus 1. And doing so allows that your function is all the same, right? So if we just bring again secant squared x equals 3. So let's go ahead and just simplify what we have. We have 2 secant squared of x. We do have a minus 1, which is equal to 3. I would add 1 to both sides, and I would get 2 secant squared x is equal to 4. I can divide both sides by 2, and that would get me 2. I would take the square root, but again, remembering the plus minus when you're taking the square root. So now think about what you have here. We can't figure out secant from a unit circle, but we can figure out cosine, right? Secant is the reciprocal of cosine. So this is cosine of x equals plus or minus, right? I would have to flop my fraction. That would get me 1 over square root of 2. Doing so helps me to see, hey, if I rationalize this, that would get me plus or minus square root of 2 over 2. I know that that's on my unit circle. So again, I think about where my unit circle would get me positive or negative root 2 over 2. And it's got to be the cosine, right? So those are all your middle angles, okay? They're all these angles right here. The cosine of positive or negative root 2 over 2. Okay, so I want you to think about your angles. So right here, that would get me pi over 4 and 5 pi over 4. And we have our next angles right there. That would be 3 pi over 4 and 7 pi over 4. All right, so now we're going to take this information, okay, and we are going to go ahead and write our answers. So the first one we have is pi over 4 plus 2 pi n. You have, again, 5 pi over 4 plus 2 pi n. From here, you know, optional way to write this is, as they are pi distance apart, you can write this as just pi over 4 plus pi n. Okay, so it's going to repeat same answers every pi. So the next one is 3 pi over 4 plus 2 pi n. And then 7 pi over 4 plus 2 pi n. And again, another way for you to rewrite this, because these are pi distance apart, you can write 3 pi over 4 plus pi n. If you want to even take this further, and again, this is, remember, totally optional, you're going to notice that not only does your answer repeat every 2 pi as well as every pi, right, depending on your angles here, you also probably have noticed that the trig equation, it repeats not only every pi, but actually repeats every pi over 2, because it's in every single quadrant, happens to be in every single 45-degree angle, right? Another way that you could write this would be pi over 4, that's your kind of starting off angle, and then again repeats every pi over 2 times n, right? So a lot of different ways that you can write this, but again, if you're comfortable with taking all your angles and then having you repeat every 2 pi n, that would be perfectly fine. All right, guys, thanks for learning with me today, unlocking the power of math one problem at a time. See you in the next lesson.